As we move into this world of connectivity and networks, a new technology paradigm is emerging. It's called the Internet of Things, or IoT for short. The technology paradigm of the industrial age was one of machines, standalone mechanized systems that were physical in nature, monofunctional and mechanized. It is a world of non-responsive, isolated technologies, each of which the end user has to manage separately. The technology paradigm of the information age is one of services. It's a world where individual component technologies are instrumented and connected into large networks of devices that can communicate peer-to-peer, adapt, and self-organize around the end user's needs so as to deliver a seamless service. One of the best illustrations of this is the smart city, where different systems no longer exist in silos, but are interconnected and organized around the end user's needs through information networks. The Internet of Things is a journey that we're just beginning on. Over the course of the next decades, billions of devices will come online. The amount of data the Internet has to handle will grow massively as vast networks of devices and machines continuously communicate with each other to coordinate production processes, for transport and logistics, for construction, climate control, etc. This will require an IT infrastructure that goes far beyond the existing capacities of the Internet in terms of dealing with massive amounts of secure data, secure communications transactions, and automated micro-exchanges of value between systems and devices on the edges of networks. This is part of what the next evolution in the Internet will have to deal with, a world of upwards of 20 billion devices constantly streaming data and making secure micro-exchanges between each other, peer-to-peer. Put simply, this world of a fully fledged IoT infrastructure to our economies will be an almost unimaginably complex system. We can think about the issues here along three dimensions. Firstly, the bottlenecks created by existing cloud-based IoT systems. Secondly, issues surrounding the security risks of centralized systems. And thirdly, enabling automated dynamic resource allocation between machines. At present, IoT systems are often dependent upon a centralized architecture where information is sent from the device to a proprietary cloud where the data is processed using analytics and then sent back to those tiny IoT devices to coordinate them. As with all centralized systems, this only scales so far. In a world of complex networks, you have to have much more processing and coordination happening out on the edges of the network, with coordination taking place peer-to-peer, so as to reduce the bottlenecks and centralized security vulnerabilities. In order to scale, you need to be able to make the decisions locally, process the data locally, and also be able to share resources locally between devices on demand. Likewise, security is of course a huge issue with the Internet of Things. More and more, we're connecting our critical infrastructure up to IoT networks. A good example being the development of the smart grid or urban transport coordination systems. The blockchain is promising for IoT security for the same reasons it works for cryptocurrencies. It provides assurance that data is legitimate and the process through which data is put into the database is well defined. A decentralized approach to IoT networks could solve many current issues. Adopting a standardized peer-to-peer communications model to process the hundreds of billions of transactions between devices will significantly reduce the costs associated with installing and maintaining large centralized data centers and will reduce the computation and storage needed across the billions of devices that will form this global IoT network. Likewise, it will prevent failure in any single node in the network from shutting down the whole system. Blockchain IoT solutions could enable secure, trustless messaging between devices on IoT networks. In this model, the blockchain will treat message exchanges between devices similar to financial transactions in a Bitcoin network, ensuring their validity. Just as a money economy allows for better, faster, and more efficient allocation of resources on a human scale, blockchain networks could provide a robust and decentralized system for handling these same issues on the micro level of individual devices and machines. The Internet of Things is going to need micropayment systems where devices can pay automatically on demand based on the resources they consume. This won't work with high transaction fees or having to wait for centralized third parties to authenticate the transactions. We really want to make it possible for one machine that has excess capacity or excess resources, like for example computational capacity, storage or electricity, to be able to sell that to another machine that needs it on demand, thus enabling an efficient load balancing system. One example that is often given of this is autonomous vehicles automatically negotiating highway passage. Say for example, one vehicle that's in a hurry, paying other cars to let it pass first. Coordinating air delivery drones is another potential use case for device-to-device micropayments, where drones may pay a solar recharging station belonging to someone else to get charged up with electricity. The Internet of Things is all about networks of technology that deliver services, where any device that can contribute to the overall functioning of the network will be able to automatically plug into that network, offering its capacities and receiving tokens in exchange. This kind of computing environment means a form of permissionless innovation layer, where anyone can start participating and contributing to any network, whether that's providing a 3D printer within a manufacturing network, a bicycle in a transport network, or a room in an accommodation network. A connected device will be able to provide services and receive payments for work done that are automatically credited to the owner's wallet, or even the wallet of the device. This will create all sorts of security, privacy, and financial issues that the blockchain is well suited to enable, as data can reside with the end device and made available only when and as needed, thus avoiding centralized security issues. One example of this is the DAV network, which stands for Decentralized Autonomous Vehicles. DAV is a blockchain platform currently under development that allows anyone to buy or sell autonomous transport services in a decentralized market. This platform integrates into any autonomous vehicles, enabling those vehicles to discover, communicate, and transact with one another using the digital token called DAV. People can earn DAV tokens by providing transport services. A self-driving car could give rides to passengers when not needed by its owner, or a drone could help with part of a delivery service. Distributed technologies like the blockchain are the missing link to settle the scalability, privacy, and reliability concerns in the Internet of Things. But of course, the blockchain infrastructure of the present could never scale to the demand that is needed. New, more efficient blockchain networks will have to evolve. One of the most promising projects in this respect is IOT, which aims to be the distributed network protocol enabling this machine economy. The main innovation behind IOT is what they call the Tangle, a new distributed ledger design which is scalable, lightweight, and makes it possible to transfer value without any fees. The Tangle ledger is able to settle transactions with zero fees, so devices can trade very small amounts of resources on demand, as well as store data from sensors with that verified on the ledger. While the whole world has adopted the so-called sharing economy in areas like driving and accommodation, IOT enables a whole new realm where anything with a chip in it could be leased in real time. Most of the technologies and devices we own remain idle for the vast majority of the time that we possess ownership of them, but through blockchain IoT networks, a lot of things like appliances, tools, drones, e-bicycles, etc., or resources such as computer storage, computational power, Wi-Fi bandwidth, etc., could be easily leased out to function in any service network.